Being able to create visualizations of data is a key step in being able to communicate information and findings to others. In this module, you will learn to use ggplot function in the ggplot2 package. Earlier, we learned how to use the qplot function in the ggplot2 package to draw graphs. Qplot function is very handy, but if you want to fully utilize the power of ggplot2 package, you should know how to use the ggplot function in the ggplot2 package. This small GIF illustrates the importance of visualizing your data. There are 13 data sets. Each time it represents a data set with associated summary statistics. Each data set has the same summary statistics to 2 decimal places while being drastically different in appearance. The key message is do not trust summary statistics alone, always visualize data. The grammar of graphics is a plotting framework. It was introduced by Leland Wilkinson. He wrote a book about his plotting framework, but he didn't implement the grammar of graphics. Later on, Hadley Wickham implemented this into a package called ggplot when he was a grad student at Iowa State University. ggplot is a very powerful and flexible tool to construct plots. You have to load ggplot2 package manually. I often make accidental use of the other tidyverse packages and the pipe operator, so I loaded ggplot2 through tidyverse, and I also load the package MacReader. I'm using Gapminder dataset and Iris dataset for illustrations. The Gapminder dataset comes with the Gapminder package. Within ggplot, there are 2 basic methods to create plots, qplot and ggplot. Qplot is very similar to the base R plot function. It can be used to create and combine easily different types of plots. However, it remains less flexible than the function ggplot. Just as the grammar of language helps us create meaningful sentences out of words, the grammar of graphics helps us to create graphical figures out of different visual elements. It's a powerful concept to organize all kinds of data graphics. The grammar of graphics establishes a building block for solid, creative, and meaningful visualizations. There are 8 plotting elements. You can think of each plot as a set of layers. These 8 elements define layers of the plot. They are called grammar of graphics. These can be thought of as nouns, adjectives, verbs for graphics. In the same sense that language grammar describes type of words and ways they can be related to each other, the grammar of graphics is the theory around the structure of graphics. Out of 8 grammatical elements, 3 of them are essential: data, aesthetic, and geometrics. The other elements are optional. Data, what we want to plot; aesthetics, the scales on to which we map our data; geometrics, visual elements that take in the plot, line, points, histograms, like that. When creating a sentence, we pick a word for the subject, we pick a word to describe the action, we pick a word for the object. Similarly, when creating graphics, we are choosing different items for these components. For example, first we select a data set to plot. Next, we select aesthetics, variables for x, variables for y, color, and shape. Next, we select a suitable geometry, line, lines, plots, like that. When you create a plot with ggplot, the basic idea is you kind of thinking as an artist's palette model. You start with basics and add things piece by piece. Unlike Bazaar, where the whole plot is coded in single function code. In ggplot, you can start with simple and customize the plot or add things piece by piece as you think more of them. Like an artist first you like an artist where he first sketch the flowers and add colors and add some more details. Similarly in ggplot, first you draw points and add colors to the points according to your need. You make little changes and add things step by step as you go. In ggplot, the main idea is plots are built up in layers. Your first plot with ggplot function. In this exercise, I'm going to use the Irish dataset. The first step is first you call ggplot function. The function input is the name of the data frame. This will create a blank canvas. Now R is ready to draw a plot. ggplot function requires data to be stored in a data frame and it should be a tidy data set. The variables that you need to plot should be stored in columns. If your data is stored in a vector and if you want to plot those values using ggplot, the first thing you need to do is you need to arrange those values into a data frame, and after that you can use the ggplot. Next layer is aesthetics. That's mapping variables. Mapping links variables to graphical properties. For example, this column represents what should be the x-axis. This variable represents what should be the color. This variable represents what should be the size, so on. Aesthetic mappings specify how you want to map variables to visual aspects. In this case, we are mapping sepal length to the x-axis and sepal width to the y-axis. Now you can see in the output, x-axis is labeled as sepal length and y-axis is labeled as sepal width. Next layer is geometrics. This tells how data should appear in the plot. Geometric objects are the actual marks we put on a plot. There are different kinds of geometrics: points, lines, box plots, densities, histograms, lot more. Based on the values given in the um, aesthetics mappings in this layer, geometry will draw the plot. Their mapping requirements differ. Here, in order to add a layer of points, I used geom points. Now the data will show up on the plot. We use dots or points elements as the geometric shapes to represent the data. A plot must have at least one geom. There is no upper limit. Note that to add layers we use a plus operator. In other words, plus is used to combine ggplot elements. By adding layers, we are adding new definitions to the plot. This is just a summary of what we have done so far. We discussed three graphical elements three layers. They are data, aesthetics, and geometrics. They are the most important three elements. First, we called ggplot Irish. This defines the data layer. All variables should be stored according to the tidy format. Next, we use AES to define the second layer. That's for mapping variables. Aesthetics informs the plot. Sepal length in iris is the x variable, and sepal width in iris is your y variable. Next layer is geometric. It specifies the object that you are going to put on the graph, in this case points. Here it is. Here is the idea. The variables are x1 and x2. They are here, and values are plotted over here. If you want, you can customize the default appearance. You can set a color to the points. Since I'm customizing the geometric object points, I pass the input inside geom point. Here I pass COL equals forest green. Now instead of black dots, I get green dots here. This is called setting a color. Furthermore, you can change the shapes by passing values to the shape argument. Here I passed a shape equals 8. Now instead of dots, I get asterisks. Further, instead of setting a color to the points, you can map a variable to the color. The variable mapping should be done inside aesthetics. Here inside AES, now I have mapped three variables: sepal length for X, sepal width for Y, and species for color. Now you can see points are colored according to the species type. Earlier, we didn't get a legend. Now we get a legend to the right of the plot. This is because now we mapped a variable to the color. Earlier we just set a color. There was no mapping. Just all the points took a specific color. Now the color is mapped. Now the variable species is mapped to the color. As we did before, if you want to define a shape for all the points, you can pass a shape 3 or shape 8, any number here inside geom points. So this visual diagram summarizes what we did in the second illustration. Now we mapped three variables, one for X, one for Y, and the other one, one for X, one for Y, and the other one for the color. So X1, X2, and color X3. Next layer is faceting. Facets defines number of panels. They are also called small multiples. This allows you to look at small subsets of data in separate panels. Here I add a new layer, facet underscore grade. Now three species types uh, are plotted in three separate panels. Um, Actually, aesthetic mapping links variables in data to graphical properties in the geometry. Facet mapping links variables in the data to panels in the facet layout. Uh, these are also called conditional plots. The relationship between sepal width and sepal length condition on species type. Facets facets are also a kind of mapping. Aesthetic mapping links variables in data to graphical properties in the geometry. Faceting links variables in the data to panels in the facet layout. If you want to arrange the panels row-wise, you can use facet underscore grid spaces tilde and dot here. This position is for rows and this position is for columns. If you want to arrange layers according to two categorical variables, then you can pass one variable for rows and the other one for columns here. Row variable here and column variable here. Next layer is statistics. Statistics layer calculates some statistics from data and the results will be plotted in the graph. Here I use stat underscore smooth. This will fit a linear regression model to the data in each panel. If you pass SC false, then you will get only the line. If you did not pass any method here, then it will use GAM models to capture the nonlinear pattern in the data. Here method equals lm, sc equals false, and the color of the line is equals to red. If you pass sc equals true, then uh, then you will get the confidence intervals as well. Next layer is coordinate. This will adjust the Cartesian coordinate system. What kind of canvas should the final data be drawn? So far the plots that you have taken were created on the Cartesian plane. There are other Cartesians built in ggplot. You can also use this layer to define polar coordinate systems. A polar coordinate system interprets x and y axes as radius and angle. We will talk more of them in the course module under the special topics in statistics, where I introduce a new course called data visualization. Here I use code equal. Code equal fixes the ratio of length on the x-axis and y-axis. The default ratio ensures that the x and y-axes have equal scales. The ratio of length on the x and y-axis is called aspect ratio of a plotting grid. Aspect ratio is the relative length of x-axis and y-axis. When creating statistical graphics such as line plots or scatter plots, It is sometimes important to preserve the aspect ratio of the data. The aspect ratio of a scatter plot has a considerable influence on the reader's impression and their ability to recognize overall trend in the data. For scatter plots, square grid is often preferred. A square grid means aspect ratio equals 1. Next layer is theme. Theme layer allows you to customize the non-data elements in the plot. In this example, I use theme layer to change the legend position. There are many other things that you could do with themes. I don't have time to go over every single option. If you want to explore further than what we discussed here, I encourage you to read the recommended textbook of the course. The last layer is scales. Scales define how the mapping you specify inside aesthetics should happen. All mappings have an associated scale, even if not specified. Everything inside aesthetics will have a scale. If none is provided, it will get a default. Scales follow a specific naming scheme, scale underscore. Then here you have to specify the aesthetic and then the type. If you use manual, then you have to specify colors for each and every level. If you want to give a continuous color scheme like light blue to dark blue, here you have to give continuous. Colors matter a lot. The scale layers can be used to specify a suitable color palette to your plots. So here in my case, scale, aesthetic color. So it's mapped to this one. Now here Sitosa took the color specified here, and the next one took the color specified here, and the last one took the color specified here. I have changed the color, the default color scheme to these colors. Finally, you can use labs to define define a plot title and customize axis labels. Title name axis labels should be passed within double quotations.